All right, so it's time for another video. This is going to be the last video for option B in the L3 VPN topology. So this video is going to be the Wireshark video. You see I made a snazzy new logo for the site. It isn't the best, but might say it isn't the worst. It can get worse than this. But let's go ahead and do those Wireshark captures. Looks like I accidentally made it my background. But we'll start with and it looks like I'm going to need to reopen GNS3. The connection to the server went down when I closed my laptop lid. But we're right back in, so let's go ahead and start by sniffing the link between the CE and PE1. And we're going to take a look at what happens when that loopback address on CE1 is no longer advertised. So we can see we've got the OSPF connection here, just like in option A. So option A and option B are just different ways you can set up Interprovider VPNs to operate between two ISPs. From the bit I've read in the documentation, the difference between the two is option B is more scalable than option A. This video really won't dive into the dirty details of just how they differ, because I don't believe that'll be on the test. I think it'll be more general knowledge and understanding of L3 VPNs. But if you can help me out in the comments and know that knowing the difference between all three of those is going to be important, please help me out. I would much appreciate it. So we're going to do the same thing in the other video. We're going to do a show route 192.0.2.1, pipe refresh 1. And now we can see we've got it as a BGP route because it is, of course, being advertised from the C1 here. There it is. So let's go in and shut that down. So we're going to set disable and then do a top. And I wish you could just stay in here and hit the commit there, but you have to be in the top. But it's not too difficult to get back. If you were on a Linux command prompt, you'd always have this history command to just go and re-enter what you had here. Here you'll just have to up arrow, but it's quite a bit back in my buffer by now, so I guess I'll just have to not be lazy for the next however long, unfortunately. So that's going to be down. We're going to see it no longer being learned here, and now hopefully we'll have something interesting to look at here in the capture. I think I'm going to have similar issues I had before where it stopped scrolling, but I can certainly just stop the capture and restart it. And now we'll go ahead and add that back in. And see what the difference is there. So looks like it's getting some hello messages now, hello packets. So let's see what the difference is when a route is introduced. So there we go. We've got descriptions, requests, updates, acknowledges. So let's stop the capture for a bit and maybe just look through these, see if we can find that actual route. So here's a type 1 LSA. These are going to be, I think, not the kind that we're going to be interested in. We're going to be interested in this update here. So here's an acknowledge. Just take note of what types of LSAs there are in these messages. So in the hello packets, it looks like we don't have any LSAs at all. We've just got the header, then the hello packet itself, and then the LLS data block. So the hello packet itself has got the hello interval, the network mask, router priority, dead interval, designated router, backup router, or sorry, backup designated router, active neighbor. But in the description, here we do have an LSA. We've got a type 1 LSA. So each description, it looks like, has a different number of LSAs. We've got one with just one type 1 LSA, and that one's coming from .1 here. And .1, I believe, is the CE. Let's check that. So run show interfaces terse, type match GE dash. And sure enough, .1 is CE. So the CE is sending out a database description packet within that database description packet. And we can see the actual bits in the packet right here. I like to have this. I always like to look at the actual hexadecimal just because it gives you a better sense of where it actually is in the packets or the frame in this case, because we're just looking at a local link. Packet, of course, would start here, so all of this here is going to be frame header information. But down here where the packet is, that's why I like to have this open, because it very clearly shows you where it starts and gives you a sense of the information you're looking at better, I think. So here's going to be the OSPF protocol information. It's going to start there. Kind of surprised there's no frame check sequence. This is kind of the most intensive use of Wireshark I have done in a while, which is good. It's going to really help me prepare for this exam. But we can see there's quite a bit of variation in the LSAs. CE sends a database description containing a type 1 LSA. Then the PE responds back with 3 type 1 LSAs and a type 5 LSA. So it says ASBR, link state ID, advertising router. Got some options. And then after that, CE responds back with the database description. I guess what I'm expecting to see, and I'm not sure if I will see that or not, is that actual 192.0.2.1 route being sent. Here we go. So we can see here's a link state ID, here's the advertising router. So it looks like it is included in this message. So this is just an updated database of the topology containing all the links. And sure enough, here's the link that is now present in this topology that contains that IP address. Whereas if I take it out, we're going to see another LS request like this, but instead of 4 entries here, we're only going to see 3 entries. And then it looks like there's updates as well. So we have all the links here. Looks like this is automatically a stub. Lots of information, but let's go ahead and verify that when I take it out, I'm going to get another LS request, but it's only going to have 3 instead of those 4 because there's going to be 1 less route. So here we go. I'm going to take out that route, set disable, and I can make it a bit easy on myself, and this is something I wanted to demo earlier anyways, and just do a rollback 1, show pipe compare. So now it's going to disable that, and if I do a commit, you can see my next rollback 1. Oops, yeah, my pipe key is quite a bit smaller on this one, but my next rollback 1 is going to remove that. So all I need to do, keep it nice and easy on myself, is just keep hitting rollback 1 and commit. So now this is gone, and it looks like we've got a new LS update. We were looking for a LS request. And I don't see an LS request. Maybe restart the capture. Do a rollback 1, or just do a commit, because that was done already. Restart the capture just to make sure it works. Oops, looks like the capture actually stopped on its own somehow. Now I'll go ahead and start the capture, open the program, and we'll get that LS request message, but this time it will only have 3 instead of 4 because it will be removing a route. There we go, there's the LS request, so I'll stop the capture. Take a look at this. Oh, looks like we still got 4. We still got the 192.0.2.1 route in there, even though that's now removed. As we can see, that's not being advertised anymore. So it's a bit of a surprise. I'm not sure what's going on there, but it's interesting to know. There can always, of course, be issues with it being a virtual environment and really not getting exactly the whole story of what's going on. So it's just interesting to dive into, something to kind of read about the theory of later and get a better understanding of. So before moving on, I'm going to actually start the capture again. And then let's take a look at what happens when I reboot this link or restart clear OSPF neighbors on one of these. Let's see what it looks like when a OSPF adjacency is formed. So edit protocols OSPF, show pipe display set. We've got the configuration here, edit protocols. So show pipe display set relative, edit area 00.2, interface, and we'll just go right there. And now we'll remove this interface. And we'll need to wait for the hold timer to expire in order for that to drop, and then we'll see some activity there, and then we'll see more activity once that configuration is rolled back. But one thing we're going to notice, see how it was 0.1, 0.3, 0.1, 0.3? Now we've only got hellos from 0.3. So it's not getting a response back from 0.1 because we went ahead and disabled that on there. So another thing to notice is we're going to have the dead interval here set to 40. So once that expires, so how long has it been so far? It's every 10 seconds. So after about 4 of these, see if there's more information about how close that is to expiring. Don't see anything. So I don't see any information about how it's going on that dead interval. I just see what it's set to. Looks like it's still just one-sided. Let's take a look at the status of the neighbor on PE1 and see if it's lost that adjacency yet. Root, show OSPF neighbor. So it looks like it's got a neighborship to the other side, but it did actually lose that neighborship already to the other side. Let's take a look at the log messages. Monitor start messages. And then roll back this configuration. So it looks like we don't get any special messaging if it loses a connection. Let's see if we get some special messaging if it forms a connection. So I've got this show SPF neighbor command ready. We'll do a pipe refresh on that every second, and hopefully we'll see a new neighbor pop up. Hopefully we'll start to see .1 hellos being sent. And we might need to go ahead and restart the capture. Let's do a show run show system rollback, or just exit and do a show system rollback, compare 1.0 to see what was done. So yep, sure enough, we added that back into OSPF. Looks like the neighborship still is informed though. Let's see if we can get the capture working. Stop it and restart it. All right, looks like the capture is working again. And yep, looks like it's now on both sides. So unfortunately, it looks like the neighborship was established, although I only see it on, oh, okay. So here's a good lesson. So we talked about how PE1 can be described like a house with a front door that has a doorbell and a welcome mat, and then the back door is going to be quite a bit different. So this front door is in fact going to be so different that you've got to specify neighbor instance. You've got to actually specify that you want that front door. So here we have the command that shows that we have that neighborship, but you can see if I don't say I want to look into the VPN2 instance, I'm not going to see that neighborship because it's formed with that special front door to the L3 VPN. So you can think of this kind of like as the porch, and then they've got to walk up onto the porch and enter the door in order to get into our VPN, L3 VPN. So I'll just hit a pipe refresh on that so we can see this dropping and reestablishing. So I'll roll back one, show pipe compare, and I'll go ahead and take that out, and we'll see it drop from here. And hopefully we'll get more information here than just seeing that the hellos are only sent from one source IP address. But here we can see that is starting to be the case. And you can see there's a lot less activity because it's now happening every 10 seconds because there's only one device, whereas before there were two devices going every 10 seconds, a little bit out of sync. So you'd have more activity, double day activity, and it wouldn't be quite as regular. There you go. So after all that time, it's about 6 hellos. We actually lost that neighborship. And it looks like it's still scrolling. So before that stops to work, let's go ahead and add it back in and see if we can capture that neighborship reforming. So already, there we go. It's looks like it went up right away, really fast. That's nice. So let's stop the capture and maybe take a closer look into it. Make sure it's reestablished. We got hellos going from both sides. So stop the Wireshark capture and take a closer look in. This all looks familiar. It looks like we've got a special IGMP v2 membership report group. So I'm not really familiar with that. I know that is going to be on the test, but right now I'm focusing on L3 VPNs, not multicast. You can see this is a multicast address as the hellos are, multicast for OSPF. But you can see these that are establishing the neighbor, they're going to be unicast on that link. So here's the database description packets. We've got one from CE1 and one from PE1 being sent across the link. We just got another hello packet. Looks like it's snuck in there. Really nothing special about it. And we've got more database description packets, but this time they're including LSAs. This is coming from CE1. It's got a type 1, 2, and 5. It's got 3 type 1s. And it's including that route. I thought that had been taken out. It looks like it had been, so I guess I'm surprised that it's including that. I think what might be going on is this is the ID of that router, but at the same time, I guess I'm not confident enough to say that. We can, of course, check the router ID. Show OSPF, and then database. And you can see here, I actually don't know what command to use to check the router ID, but that's what the question mark is for. So perhaps overview would be a better command. Perfect, yeah. So we can see that's actually not the router ID. Router ID is that public IP address. So I'm not sure what this is going to be. I'm pretty sure this is a public IP address. It could be extending past the Class C range. Nope, it's going to be a Class C public. The Class D, that's going to be experimental IP. So if it would have extended into this range here, then it would not have been a public IP. So this is why I double check. So the Class E is going to be for future use, development, whatever. Those aren't going to be public IPs. These, of course, aren't going to be public IPs either, but these are your multicast groups. So, of course, the hellos, those are going to be in that Class D range, but Class C addresses are all just run-of-the-mill public IPs. Unless, of course, they're reserved for private. They're in the 192.168.0.0 range to the /16. All right, so moving on, we found what happens when it forms a neighborship. Looks very similar to what happens when it introduces a new route. Got description, requests, and updates. So lots of interesting stuff happening there. Kind of a bit too much to dive into and finish up the rest of those links. So let's kind of put this aside for now and take a look at the rest of those links in the topology. So let's start with that link there, and we'll just see what it looks like with it added in. Don't need to look at this anymore. All right, so same as before, we've got RSVP, OSPF, TCP, which is just BGP. One thing I'd like to do is kind of narrow it down and look at it one by one, maybe even deactivate, do a similar thing as before, and see what happens when I deactivate the protocols. But for now, let's just see if there's any changes when I reintroduce this route. And you'll see, unfortunately, here, if I do a show configuration commit or show system rollback compare 1.0, I've got what I did for OSPF. If I do 2.1, I've got that as well, because I both took it out and added it in. But if I look at some of my older commits, right here, this is the one I want to do, but unfortunately, I'm unable to go ahead and just do a rollback 5, because as you'll see, it's, oh, well, because, okay, so this is working because I already have this committed, but this could be, if I didn't have the changes already in those other ones, this would include that. So kind of a bad example. One thing I think I can do is do a rollback 0 and then a rollback 1. So now if I do a rollback 5, you can see this disappeared because part of the rollbacks after rollback 5 were to re-add this. So if this command worked so that all it did was roll back this commit number 5 and not all of the ones up till the running config as well, then you'd still see this under the show pipe compare, but that's not the case. So I'm going to do a rollback 0, and I'm just going to do a rollback 5 because it's doing what I want to do. But make sure that if you do that, you're always doing that show pipe compare. So what you want to do is happening, and then I'm going to get rid of that disable, and the route is going to come back, and then we'll see the same BGP update message that we saw before. There it is. So I'll stop the capture. And we'll take a look at that. So here's the withdrawn routes. Looks like there aren't any. Here's the path attributes. Origin, AS path, multi-exit discriminator, local preference, extended communities, MP reach, next network layer reachability information, address identifier, all sorts of good stuff. So that's one. Let's go ahead and filter out for BGP. Looks like we got 3 update messages, so all varying lengths. Here's a withdrawn route. So NP unreach NLRI IPv4 prefix. Looks like it was withdrawn, which is interesting. This is something I haven't really gotten to the bottom of yet because you can see it was added. So maybe it was withdrawn from a particular, but it was never being advertised. So it's definitely a bit of a mystery there. But yep, nothing new, nothing special. So I'll clear that, and let's go ahead and tank this BGP connection and then see what we get when that neighborship is reformed. So I will need to open up PE1, which is going to be this 2.2, I believe. I'm not sure about that. I'll need to double check. Show configuration, pipe display set, pipe match 192.1.0.2. So I'll need to move myself out of the way here. And I can see, yep, this is 2.2, and I've got a label switch path to ASPR1. So let's go ahead and shut down that BGP neighborship. I believe I can just clear the neighbor. Clear BGP neighbor. And it's going to be, I can just do all. I've only got one neighbor on this one. So one connection is cleared. Take a look at the show BGP summary. That's inactive, so do a refresh. And hopefully we'll see that transition back to established as it was before, and then we'll get all of the traffic in Wireshark that shows that transition. It looks like it's still inactive. I'm not sure how long this will take. Here we go. Now we're in connect, open sent. Open confirmed is next, but that's the one that I mentioned before that is going to be in milliseconds, pretty much impossible to sniff out. Be able to see active to connect to open sent, but from open sent to established, the transition from open sent to open confirmed and from open confirmed to established is just too fast to see if you're looking every 1 second. But hopefully we've got that here, and it looks like we did not, so I'll go ahead and just do that again with a fresh capture. Oh, it looks like the capture was actually stopped. So I'll go ahead and start that, and we'll go through that process again. Maybe we can get a open confirm. So show BGP summary pipe refresh. Let's go ahead and do the reset on the ASBR so we can keep that running. We'll filter out just for BGP over here, so we're not seeing extra traffic. Clear BGP neighbor, and here we're not going to want to do all of them. So it's going to be 192.0.2.2. So this went into active and went straight from established to active. Now it's going to take about a minute as it did last time. But it didn't take all that long last time. So unfortunately I just got to wait. So it looks like there's kind of no difference here. It looks like they're both, oh, here we go. Here we go. So now we've got, instead of just keep alives, we've got a plethora of different kinds of messages. So I will stop the capture and we can go and look at some of those messages. I can stop here because it's already established. So let's take a look at the first notification message. It says cease, which makes sense because we went and dropped that connection and it went from established to active. So that's the one I would think would be the first message we would see. Got some optional parameters here for multi-protocol. So this is MP-BGP. And that's coming from the ASBR. Here's coming from the PE. It's like they exchange these open messages. So this looks like the open confirm. It's got graceful restart. So let's move on to the next notification message. So this is, looks like a connection collision resolution. That's interesting. That's a minor error code. Now we've got another open message, another set of open messages. So this has a 1, whereas this one, yep, that one had a 1 as well. So it looks like there's no differences. Long-lived graceful restart capability. So this looks like a special message and it's from the ASBR. And it looks like it's a notification as well as an open message. We got kind of 2 for 1 in this one. And here's the final messages, which are updates, extra path attributes, from PE1 and from ASBR1. So that was interesting. Let's take a look at RSVP. What happens if I disable the connection with RSVP? So hopefully the capture will keep going. I'm gonna go ahead and now this is going to be, instead of from PE1 to ASBR1, if we look at the show RSVP neighbor command, we're going to see it's going to 192.0.2.3, which is the P router. So unlike the TCP protocol BGP, where it rides on TCP and it goes through multi-hops, this is just going to go right across the link to its most immediate neighbor, P1. So if I do I log into the device and do a show configuration, pipe display set, pipe match, 192.0 dot, and then it's going to be 2.3. You can see that's the loopback address. So we'll go ahead and shut that. Well, let's not shut that down because we'll lose the other protocols as well. Let's just disable RSVP for that on this device. So show configuration, protocols RSVP. So it looks like we've got that interface in there. So we'll get rid of that interface. Take a look at what this is. So show int terse pipe match G dash. So it looks like it's got two connections, one to GE000.0 and one to the loopback. So we can do one at a time or them both. I'm thinking just shut them both down. So we'll do a pipe refresh on here every second. And then over here, we'll go edit protocols RSVP, show pipe display set relative, and delete everything here. Yes. Show pipe compare. So now we're going to commit this and see what kind of changes we get here for RSVP. Maybe just confirm that we're going to get a 107th packet before moving on to make sure it's still capturing, because we didn't make any changes yet. And it looks like it's been about every 6 seconds or so. So it's definitely been longer than 6 seconds now. So I think just to be safe, I'm going to stop the capture and restart. Okay, and now filter out for RSVP and go ahead and commit that change. Jump over to P1, see those neighbors drop. Looks like they're both still up. We can see there's a number of new packets here to look at. The neighbors, oh, so it looks like there's been an update to the command here. We've got the down count incremented for both of those neighbors. So let's go ahead and stop the capture, or maybe bring it back up and see what that looks like. Pull back one, commit. We'll see that down counter looks like the up incremented. So maybe the down will decrement now. I don't see it decrementing. Let's take a look at C2 and try adding that route back in and see if it actually makes its way down there. If it doesn't, we know we've got an issue. And actually it looks like it's already, okay, so yep, now it's down there. So it was already advertising it. It looks like the down counter never decremented, but the up counter decremented. And the route's being learned, so there's no issues there. So let's stop the capture and take a look at what happened in RSVP. So we can see just our regular hello messages. We've got .2 from PE1, I believe, and then .4 is from the P router. So let's take a look at the P router, show int terse, type match. Yep, so 4 is sure enough the P router, 2 is the PE. So the P router sends this hello with restart capability. All of this looks very familiar to me for having gone through the JNCIE-SP. What looks especially familiar is these RESV tear messages and these path error messages. So it looks like those are preceded by this component messages dissected. So we got a RSVP header here. We've got a tear message and then a error message. So lots of information here. Token buckets, that's interesting. So path error, path tear, path error. Lots and lots of information there. Fixed filter, that's something to take note of. So lots of information with RSVP. Let's keep moving through. Here's the path tear message, or the RSV tear message. And then next is the path error message. So here's the style fixed filter. I know that is relevant. Got a tunnel ID, extended tunnel ID. Keep looking through the next ones, see if there's anything interesting. Looks like it's recording a route. Record route object. Of course, interesting. System error. So lots of information in RSVP. And these look like more of the same that we've seen before. I don't recognize that add spec just because I didn't look into it, but it was included in those other ones. Controlled load, defaults. So yep, lots of really granular, detailed information. There's an ACK message. Okay, so I guess nothing to really look at unless you know what you're looking for. Just kind of a bit too much information to really take in and understand, unless there's really something to kind of investigate. So, but anyway, it's just interesting to see some of the terms I'm familiar with having studied for the other exams, and seeing them kind of in a different context here, one that's going to be a lot more relevant to the real world. So I think we've got one more protocol left, but that's just OSPF, which we already did on the other link. So let's move on. And again, I'm not sure how long this video is going. I actually forgot to set my timer, but I get the feeling that it's going long. So I'm gonna shorten this one up and skip this link, because that link is gonna be the same as this one. And then just look at this link closer. And we'll just see that BGP update, and I think I'll be able to end it there. If there's anything anyone really wants me to look at in the next one, because I'll be doing another Wireshark analysis like this for scenario for option 3 before moving on to a different topic in the exam, let me know in the comments, help me out, tell me what you want to see, and I will certainly include that. All right, so let's go ahead and look at the last link that I will include in this video. So stop the capture here. Oops. Okay, I already stopped it. This one's going to be quite a bit different as well too, because you've got BGP going on each side. And it might be interesting to look into that withdrawn route some more too, see if that's going to be included there as it was last time. But for now, let's just look at this link. Okay, so this is back up. Do a rollback 1, show pipe compare, commit. So this is going to disappear. You should see an update. There it is already. And usually there's more than one. So we've got one from .8, and then another keep alive from .8. But it looks like that's the only update. So I'm willing to bet that .8 is going to be ASBR 1, because the change was made from CE1, so it traveled along this way. So I'm willing to bet .8 is ASBR 1, saying that I have a difference now, and the difference is I no longer have that route. Show configuration, pipe display set, pipe match 192.168.3.8. So sure enough, .8 is on ASBR 1. I think I can stop the capture now. And then let's look into this update message some more. Withdrawn routes, path attributes. So very interesting, of course, that it's included as a withdrawn route. It's a NP unreach NL network layer reachability information. So it seems like it's can't reach that, even though it's in this case, oh, well, okay, well, in this case, that makes sense, because what we went and did is took it out. So let's actually do one more capture on this and see what happens when it's added back in. Is it still going to be a withdrawn message, or is it going to be in any way different? Filter for BGP. and then roll back, commit. Now this will re-enter, and we'll see if we get another update message from BGP, and if it includes a withdrawn route. So if it does, that would be interesting because we're actually going ahead and adding a route. So it could be that there was an active route that this replaced. So since that route is no longer active, it was withdrawn, and an additional BGP update message had to be sent out for that process. So it looks like we've got 3 update messages. We've got path attributes, originated in the IGP. Extended attributes, carried extended attributes. Okay. More path attributes. Oops, so here we've got the prefix. So now here it says MP reach NLRI. I believe it said unreach earlier. So that's interesting. And that's, you can see there's no withdrawn routes, length 0. Instead, we've got path attributes. So this is more what I was expecting to see. So within the MP reachability information, we've got what we were looking for there. So that's really good indicator of that's really intuitive. I think that really is what I expected to see. So here we've got some unreached information, and we've got withdrawn routes. So this is where I would expect that there was some other kind of route that was active, but this went and took that over and made it inactive. But here we can see it actually is that same prefix. So I'm not sure why that is the case. We can compare the information side by side. So just get the relevant sections. But of course they are going to be different because this is going to be reach information and this is going to be unreached information. So we've got BGP prefix information on both, but one is going to be prefix information for network layer reachability information, and the other one's going to be for a withdrawn route. So perhaps it's just saying that the label stack, that there's a change in the label stack, something like that. But that's, I guess, a mystery to think about, but you can see the difference here. It's NP reach, multi-protocol, network layer reachability information, reach. And here it's unreach. So some really intuitive, clear language being used there. We've got another reach. We've got the label stack here. So it's kind of not as unintuitive as it would seem. Perhaps this is associated with some sort of label swap or pop or push or something like that. It's, since it popped the label, it shows up as a withdrawn or some sort of information that ties into another protocol somehow. But in any case, I think this was interesting, and it kind of found a intuitive way to look at those update messages. Just look at it, whether it's reach or unreach, and kind of have a better understanding of what's happening just through those words that can be understood more clearly. So let's perhaps just take a look at the last link that I want to look at that's not similar to all the other ones. So that's this one here. We'll see if we get more reach, unreach. Won't need this ASBR anymore. Filter it down by BGP. Remove the route. And then we'll get the update message. And this is for the route being removed. So we're definitely going to get some unreached messages in the update. You can see we've got withdrawn routes. So that's good. That's intuitive. That's what we expect to happen. Now, what's interesting here is you'll notice this is just plain old vanilla regular message. There's no special, you don't see NP anywhere, multi-protocol BGP, anything like that. Well, that's because we're sniffing the link here. So this is just a plain old BGP connection here. This is not a multi-protocol BGP connection, MP-BGP. So if I go to CE2 and I look at the configuration for BGP, you can see we've just got a regular BGP group here. And I'll start that, I'll keep that refresh going, and then I'll go into PE, PE2, and we'll actually see side by side on there what the difference is between a BGP configuration where you won't see MP, multi-protocol, you won't see all those NLRI messages, all that extra stuff. You won't see that in there. We'll see the difference between that and this. Display set, pipe match BGP. So here we've got a group going to ASBR2. And here we've got a group going to CE2. And we can see there's a difference between the two. Of course, the one going to CE2 is in the routing instance, and the other one is just in the default instance. But when it comes to all of this information, we can see this is part of a VPN. It's an iNet VPN unicast, and this one is not. So they're going to look quite a bit different. And I'll actually go ahead and sniff this. You can have more than one capture going at a time. And we'll look side by side those update messages and see how they're different if BGP is multi-protocol being used as part of a VPN, or if it's just plain old vanilla BGP. So this is going to scroll, this is going to scroll. I might have stopped the capture, so I'll just restart that here. I'll just restart it anyway, just to get a fresh capture. So start capture, all right. And hopefully it's scrolling on the other one. This looks like there's not many keep alives being sent, so I can always just restart this one as well. I think I'll do that quick. Just to be sure. Okay, and now I'll restart this one. Filter out for BGP. Okay, and now hopefully I'll get more than one hello message. There we go. So now I'm more confident that it's going to work. Looks like this is saying PE2, even though it's saying CE2 up there. So I'm not sure. Okay, it's just my tabs were different. So let's go ahead and add that route back in. And then stop these captures and take a look at the update messages and how they differ depending on it being Np-BGP or just regular vanilla BGP. So there it is. So we've got our update here, updates here as well. Oh, I didn't filter out over here, but I can do that afterward. So yep, there's the updates. Let's go ahead and stop the captures and take a look at how it differs. So here's the update for Np-BGP. You'll see we've got extra path attributes, including Np reach NLRI, because we added the route back in. So it's going to be able to reach it now. So we've got that reach as opposed to the unreach if we were to take it out, and then we get withdrawn messages. So Np reach. We can see we've got address families, so just a lot of extra information, path attributes, all that sort of thing. But if we come over here and we take a look at the update message, you can see we've got network layer reachability information as well. And we've got path attributes as well. But the network layer reachability information is going to be a bit different. So here we can see the path attributes are similar. It's going to be in a additional AS. It will have left AS 200 to get to the CE, so it's going to include that in the path. It's got extended communities, but you can see there is a difference here in that this is included and it says NP reach NLRI, whereas this does not have that kind of attribute, and it just has another section that says network layer reachability information. So you can see there's quite a bit of differences in the packets when you include it as part of L3 VPN instead of just including it as vanilla BGP. I'm wondering if the route distinguisher will also show up in there. Probably going to see the community. So here's the route targets. It's kind of what I expected to see. Wonder if there's going to be, so there's clearly not going to be a route target on this side because it doesn't even have extended. So it looks like it does have extended communities, but oh, it does have a route target here as well. So that's interesting. Just kind of passes the route target back, even though it doesn't really need it for this side. It's going to need it. You would have, I guess I would have thought that that information would be stripped as it's leaving the L3 VPN, but you can see that's very clearly not what happens. It's still on there. So yeah, I think that's the video for today. I'm not sure how long it is. I forgot to set my timer, but we did a lot of things that I think were pretty interesting. We looked at the OSPF update messages, the new LSAs that are going to be sent out when a new route is introduced. We looked at a neighborship forming. We looked at what happens when you stop adjacency as well. We looked at RSVP, a neighborship forming in RSVP as well. We looked at one forming in BGP. Then we looked at closer into some BGP update messages. We saw the difference between a reach and an unreach NLRI. And then just now, we looked at the difference between a BGP update as part of a L3 VPN and a BGP update for BGP that is not configured within an L3 VPN. And you can see there were some, we just don't have this MP prepend, and we've got network layer reachability information as its own thing and not included as a path attribute. So thanks for watching. Hope you enjoyed it, and I hope my audio was not as bad as it has been. Have a good night.